Hello, this is PI with Mike. Welcome to Supervised Machine Learning Zero to Production. Most machine learning tutorials teach you to train a model. This series teaches you to build something real, a model that lives on a server, takes requests, and returns predictions. By the end of this playlist, you will have built and deployed a supervised machine learning system from scratch. No shortcuts, no black boxes. The project we are going to be working on in this playlist is based on a customer churn data. I chose this because the data is clean enough to focus on the ML concept, but it will be realistic enough that the lessons transfer directly to actual production work. There is exactly what we are building. Raw data comes in from cargo. We clean it, analyze it, engineer the features, then we train a model, evaluate the performance of the model, then wrap it in a FastAPI application. We containerize it with Docker, then we deploy it to cloud. Every single step in this series. Here is what we are going to be using. For our core programming language, we use Python. And for our machine learning modeling, we use Scikit-Learn and evaluation. We use pandas for data manipulation and processing. We use FastAPI for our API, Docker for containerization, AWS, GCP, or Hetzner for cloud deployments. If you have not used any of these before, that's fine. We will introduce each tool when we need it. You need to be comfortable with Python, with things like classes, functions, loops, file input and output, testing, and so on. You also need to be familiar with pandas, things like reading a CSV and creating columns, cleaning data, changing data types, and so on and so forth. A rough idea of what a machine learning model actually is: you do not need to know Docker, FastAPI, or other cloud platforms. You don't really need a deep statistics background, just some basic mathematics. We will introduce each tool and concept when you need it. For this course, you need to have VS Code installed, which you can search for in Google, Visual Studio Code. So you can either download for Mac, Linux, or Windows based on your hardware. I already have it installed here. You also need to ensure that you have Python installed. And for you to confirm that, you can just type Python version or Python 3 version. So I have it installed. The next step for us now is to create our virtual environment. We do that using Python or Python 3 -m. Then you tell it that I want a virtual environment, which is the first VENV. Then you can give it any name. You can give your environment any name, something like MLM. So after that is done, we need to install our requirements. So you can install these requirements in two main ways. There are other ways to manage your packages, but we'll be using two main ways using the same package manager, which is pip. So we can create our requirements.txt. We can then list out the requirements that we need: Scikit-Learn, pandas. You do not need to worry about how I came up with this list. For now, we would explain everything as we proceed in this series. Pandas, Scikit-Learn for modeling, like we said, pandas for data manipulation, NumPy for also data manipulation and things like matrix and vector operations. We also need matplotlib for plotting images, plotting graphs, and so on and so forth. We also need Seaborn, also for plotting. We need FastAPI. We need UVCon, and we also need joblib. So you could either install this using something like pip install Scikit-Learn pandas numpy matplotlib cbon FastAPI UVCron joblib by listing them out, or since we already have it listed in our requirement.txt file, we can just do pip install -r recursive requirements.txt. So it would install our requirements for us. So while that is running, we need to set up our project structure. Now, we would be following clean architecture, solid principles, but not to the letter. And why we need to do this is we need to start building a mental model of how to work in a production environment, how to build things that is easily maintainable, that is easily onboardable for other people when they are onboarding onto your project. So we need to create our main.py, which is the entry point. This would serve as the entry point for our API. We need a Docker file. We need a README for our main documentation. README.md. We need an example environment. You don't have to worry about all this for now, but it's just like a foundation that we'll build upon, and we'll see why all these are needed as we proceed. We need to have a data directory for the data we want to train our model with. Then inside data, we are going to have two subdirectories, which is raw data and then processed data. In our root directory, we also need a models directory to store or to save our model artifacts for later use in prediction. We also need scripts, a script directory, which will contain scripts to actually train our model, and things like inference, training and evaluation, yeah. We also need our SRC, which would serve like the main parts where our API is orchestrated. Inside SRC, we'll need to have our config to have things like settings for our API, config directory. We also need to have our domain directory for business use case, which would expand on as we proceed. We also need to have our infrastructure layer. Inside infrastructure is where we have other things to connect with, things like database, external clients when needed, repositories, and so on and so forth. So we're going to have our DB layer inside infrastructure. We are going to have our ML layer for real-time preprocessing and inference. So we have our ML. We also need to have our repository layer. This is where we are going to have our SQL or ORM SQL alchemy queries, which would expand on as we proceed. We also need to have our services layer. So this is like the foundation that we're going to build upon for this entire playlist. We might add or remove some based on our project requirements, but this is the foundation that we are going to be building upon. In our next video, we will start with the fundamentals of supervised learning. What is actually supervised learning? How classification differs from regression, and the concepts that will make every algorithm we train later make sense.